In this video, we're going to learn how to compute the greatest common divisors using Sage. And so let's get started with that. This is going to be just a very basic computational video. None of this will be difficult at all. So we did this example where we had the integers. What did we have? We had, I think, 462 and we had 10 something, 1071 or something like that. Now, what we did was we had an algorithm that computed the greatest common divisor. So Sage actually has that algorithm programmed in, and we can ask for, what are we computing? We're going to compute GCD of, so parentheses means of, 462 and 1071. So let's see what happens when we evaluate that. Okay, so down here, it computes it for us. We got 21, which is exactly what we found. And that's because the Euclidean algorithm is insanely efficient. It's what's running in the background, I'm pretty sure. So we had that. And how do you compute a GCD? Well, you can do this. So we can do negative numbers here. We should still get 21. We can put a 0 here. We should get positive 462 in that case, because GCD is always positive. If we put 0 and 0, we should get undefined because you can't, there's no greatest common divisor of 0 and 0. It defaults it to 0. That's the meaning it's undefined. Let's see, what else? So let's go back to our 462 and 1071 example. So we computed that. And we also found that, let's do some math in Sage. So I want to check that our Bezout coefficients that we found were correct. So I think that we found, if you take 7 462s and you subtract off 3 1071s, you get 21. So we're going to do the asterisk symbol, which is Shift 8 on your keyboard to multiply. And, well, oops. Yeah, let's just make sure. I'm going to do something here just to make sure it's doing the right thing. Say, let's print the sum or something like that. Okay, so the sum is 21, and in fact, if I got rid of that line, that is also 21. So only this is printing. You can see that this gives us the right combination. Now that's all fine and good. How can we find the Bezout coefficients in Sage? Well, GCD of 462 and 1071 use the Euclidean algorithm to compute the GCD. And the way in which you find the Bezout coefficients is called the extended Euclidean algorithm, where we sort of solve for our remainders. We're just going to put an x in front of it, and we're going to see what the output is. And again, the x here stands for extended. Okay, so we got 21. We got 7 and negative 3 as a list, as a tuple. So what this is returning for us is it's returning for us the GCD and what I need to multiply 462 by and what I need to multiply 1071 by. Let's just make sure that's correct. What happens if we swap the order? The GCD should stay the same. It should stay as 21, but these likely swap order, or they might change entirely. Oh, they just swapped order. Okay, yeah. So, all right, cool. Now, actually, xGCD is a function, and functions don't need to return only numbers. They can return lists. So let's figure out how to grapple with this. I'm going to define d, x, and y, or sorry, I'm going to do yx. Let's go back to the order in which we had it before. So d is going to get assigned, the letter d is going to get assigned to the first thing in the list, GCD. X will get assigned to the second thing, and y to the third thing, where I've swapped it. So the new second thing is 7, and the new third thing is negative 3. Let me just actually just go back real quick and evaluate it to what I want it to be. Oops. Oh no. Dx, y equals. All right, so x will be 7 and y will be negative 3 if this works. Now, when we click evaluate, nothing's going to happen because we didn't ask it to print anything or to show anything. We just said, hey, d is going to be the first thing, x is the second, y is the third. Let's go through and let's print each of them. Print just means display. So, yep, sure enough, d is 21, x is 7 and y is -3. And we could ask it, is it true that x times 462 plus y times 1071 is the right thing? Well, we could do that in one of two ways. We can just have it output that. Sure enough, we got 21 when we do this combination, which we should. Or we could ask it a question. We could ask it, is it equal to 20? Is it equal to D? So is it equal to is a double equals, and it's asking, is the left-hand side and the right-hand side the same? So this returns true if they are, and it returns false otherwise. So the left and right-hand side are the same as we expect. If we were to add 1 to D, so D is 21, right? So D plus 1 is 22. It should now say false, and it does. Okay. So this is how you do how do you compute a greatest common divisor in Sage, and also how you find the Bezier coefficients in Sage as well. You use the XGCD. X is for extended.